Hello. So we want to have a small discussion here, and I don't want it to take more than 1 hour. We want to discuss something on carbohydrates. Yeah. So we want to know the structure of carbohydrates, what they are made of, types of carbohydrates, and many more inside the discussion. So let's just dive in and see what is there. So we'll just start off. Let me select a pen here. We're going to use a red pen for the topics and subtopics, or rather subheadings. So the first one, let's type here carbohydrates. Yeah, carbohydrates. If you read this word, it's like two words, carbohydrates. So sounds like there are two words. Don't worry about my hands, those are gloves, glove powder. So carbohydrates, those are simply two words, yeah, from carbon and hydrates, yeah. Whenever you hear of the word hydrates, yeah, water will come into your mind. And carbo, that definitely means that there are connected carbon atoms inside here. So when you say carbohydrates, it simply means hydrated carbons, yeah, carbohydrates, hydrated carbon. And the formula for carbohydrates is always CH2O in bracket N, where this N always represent the number of carbon atoms. Yes, and for glucose we always have 6 carbon atoms, yeah. So if we substitute the N with 6, we are going to have CH2O multiplied by, now we multiply by 6, not N again. We multiply by 6, and that will give us C6H12O6. So practically this is the formula for carbohydrates. Okay, let's move forward. So bodies, or rather organisms, are built up of biomolecules, carbohydrates being one of the biomolecules. So maybe to mention on the biomolecules that build up the body of a living organism. Biomolecules. Number one, we have carbohydrates, whatever we want to discuss here now. Carbohydrates. Number two, we have proteins. Number three, we have lipids. And number four, we have nucleic acid. So these are the building blocks of the living organism. So even you, yeah, your body, these are the building blocks of all living organisms. So for now, our focus is going to be on the first one, carbohydrates. Maybe the remaining can be discussed later. So let's just start off. Let me write it again. Carbohydrates. We already have the formula. We already have the formula. So carbohydrates, we have different types of carbohydrates, and they are categorized in one, we have monosaccharides. Two, we have disaccharides. Don't worry, these handwritings, they are not good. I'm not using a pen. I'm just using my index finger to touch the screen. Yeah, so that's why the handwriting is worrying, but don't mind about that. Number 3, we have oligosaccharides. And number 4, we have polysaccharides. Polysaccharides. Yeah, so mono simply means one. Yeah, mono means one. Saccharide is a Greek term or Greek word that means sugar. Yeah, so monosaccharide is a simple sugar. Yeah, it's only one sugar, so it's a simple sugar. It's just one. We go to disaccharides, just as the name suggests. Di means two, so disaccharides is made up of two simple sugar, or rather two monosaccharides. Yeah, two monosaccharides. Now we have the oligosaccharides. Oligo means made up of 3 to 9 monosaccharides. And now we have the poly. Poly means many. Yeah, if you hear the word poly, yeah, poly means many. Polyagglutination, polytechnic, polycythemia. Yeah, so poly means many, and here we have more than 10 monosaccharides. More than 10 monosaccharides. So up to this point, I hope we are okay. So we are going to discuss these sugars, and I'll only measure on monosaccharides and disaccharides. Those are the ones that I think I'll handle now. So let's write number 1, monosaccharides. We are going to start with that. Monosaccharides. The formula is the same. It's a glucose, so the formula is just what we already wrote up there. So monosaccharides, we also have sugars. We also have a number of simple sugars known as monosaccharides. So these simple sugars, we'll just mention a few. Number 1, we have glucose, very, very common. I'm sure you always heard of the word glucose almost everywhere. Number 2 is galactose, which is not very, very common in terms of popularity. And then number 3, we have fructose. Number 4, we can have mannose. So we can only deal with these ones at the moment. So all these ones here, they have the same formula. Yeah, but why different names? Yeah, they have same formula, same number of carbon atoms, but now different names. What's the reason behind that different names? So they have 6 carbons. They have 6 carbons. And at one point, or rather during your early education, you know that when you hear of a diagram that has 6 corners, yeah, that will be known as a hexagon. Yeah, so glucose The suffix for glucose is always OSE. Yeah, that is the suffix for glucose. And the 6 is hexagon. So when you combine hexagon and OSE, we will be having a sugar as our end product. But before we do that, we are going to remove the gon. Sorry, I left E here. Yeah, I left it there. So we are going to remove the gon so that we can now have the final product. The OSE will take the place where the gon was, and we're having hexose. Yeah. So when you hear of the term hexose, these are sugars with 6 carbon atoms. Yeah. So all these glucose up to mannose, they have 6 carbons, hence they will be termed as hexose. So when you hear the word hexose, just know that there are 6 carbon atoms somewhere. Up to that point, I believe we are very much okay. So we want to start discussing, or rather knowing, the structure of each and every of them, including their linear structure and their cyclic structure. The linear structure is the Fisher projection, and the Haworth structure is the cyclic projection. Yeah, so linear is Fisher projection, and cyclic is a Haworth projection. So let's start with glucose. I don't want to take much time. Let's start with number 1, glucose. So remember, I said same formula, C6H12O6. And after drawing, we want to confirm if we are having the same formula as the number of atoms that are in the structure. So glucose, we will start with the Fisher projection, which is the linear one. So we are having 6 carbon atoms. Let's start by drawing those ones. 6 carbon atoms. 1, 2, 3, 4, 5, and 6. And we can join them. We can bond them. So we have joined them. Yeah. The first carbon atom, carbon number 1, number 2, number 3, number 4, number 5, number 6. The first carbon atoms for glucose is the one that contains the functional group, and the functional group for glucose is an aldehyde. So to draw aldehyde, you can decide and draw it this way, CHO. You can decide and make it that way, and if you want to draw a structure, you will make it to be, yeah, if you want to draw a structure form, you let it be that way. So we are going to have our oxygen here and the H here. So that is carbon number 1. Yeah, we want to make it easier. Let's start with carbon number 1, then go to carbon number 6, which is the terminal group. Yeah, it's the terminal carbon, and the terminal carbon has OH, it has hydrogen, Yeah, so this is the 6th carbon, which is the terminal carbon. If you want to avoid all this, maybe you don't want to write those ones and make your work easier, you can just make it to be you can make it to be CH2OH. Yeah, CH2OH. Now we are going to carbon number 5. Carbon number 5 is the carbonyl carbon, and the carbonyl carbon is the sub-functional group, and it has the OH. Yeah, so let's put OH here to the right. Another thing, when you are drawing glucose, carbon number 2 to the right, we have OH. Yeah, I hope you're getting that. Then carbon number 3, we have H. Then carbon number 4, we also have OH. Then now we come to this side. Whatever is to the right, sorry, carbon number 6, we don't have anything down there. So on the right, what if you have OH to the right, on the left you are going to have H. On the right we are going to have H. And for this one, number 3, we have H. So this side we are going to have HO. And up to now, I'm sure maybe you're asking yourself, why this side we are having HO, and when it comes to this side we are having, sorry, this side we are having OH, and when it comes to this side we are having HO. So we are having HO simply because we want to directly link this carbon to oxygen, reducing the distance between them to increase or to aid in its reaction with carbon, yeah, during the solubility. So that's understood. That's why it's HO. And carbon number 4, we are having OH to the right. So this side we are going to have H. Then also number 5, we are going to have H. So we've drawn the linear structure or Fisher projection for glucose. Now we want to name this glucose as either D glucose or L glucose. To name it as L glucose or D glucose, we are going to focus on carbon number 5. And carbon number 5, we are going to focus on the OH. Sorry, we are going to focus on the OH. Is this OH to the right? We are going to focus on the OH, and whatever we are going to check on, is OH to the right or is it to the left? When OH is to the right at carbon number 5, that is going to be a D sugar. So this one is D glucose. This one is D glucose. So when you want to draw L glucose, yeah, everything remains, but for L glucose, it is a mirror of D glucose. So whatever was on to the right, you take them to the left. What I mean is that when you are drawing L structure from here, whatever is to the right, you take them to the left, and whatever was on the left, you take them to the right. So let's draw it faster and note the difference. So C1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Carbon number 6, CH2OH. Carbon number 1 is the functional group. So we start joining these ones. Carbon number 1, we said whatever was to the left, we now bring them to the right. So for D glucose, we are having H to the left, so we'll bring it to the right. We are having OH, we are having H, we are also having H, and the other side we are simply doing the same. So carbon number 2, we are having H here. Now we are going to have HO, we are going to have H, we are going to have HO, we are going to have HO. So this one is L glucose. So this one is L glucose. If I'm told you are having any question, maybe you'll type them in the comment section. So this one is glucose, both D glucose and L glucose, and I'm sure you've noted the difference. So let's go to number 2. We're going to be a bit fast. Number 2, we want to see galactose. Number 2, we want to see galactose. So galactose is also having same formula. Yeah, galactose is also having same formula. Let's draw the structure of galactose. So we have C1, C2, C3, C4, C5, sorry, C5, then C6, where we are having the CH2OH. Don't forget that, yeah? At the terminal carbon, we are having the CH2OH. And now let's link them. We link them. The functional group remains the same, aldehyde for galactose as well. Now we have carbon number 2. We want to join them. Yeah. So at carbon number 2, it's simply the same as glucose. Carbon number 2, OH is going to be to the right. Then we are going to have H here. At carbon number 2, we are also going to have H. At carbon number 5, we are going to have OH. The other side, we are going to have H. We are going to have HO. We are going to have HO here, and we are going to have H. So up to this point, I'm sure maybe you have spotted something that is not common. Yeah, it's going to be unique between galactose and glucose. And now you'll start knowing why they have same formula but different names. So when you check on carbon number 4 for galactose, carbon number 4 for galactose, and you go to carbon number 5, sorry, you go same to carbon number 4, carbon number 4 for glucose. I'm sure you've noted something. For glucose, OH is to the right. Yeah, OH is to the right. And for galactose, OH is to the left. Yeah, so that's what differentiates galactose and glucose. Yeah, so this one we can term it as a stereoisomer. Yeah, same number of carbon atoms, but they differ in the configuration at a specific carbon, which is carbon number 5. Yeah, same formula, same number of carbon atoms, but they differ in configuration at or around a specific carbon, which is not a carbonyl carbon. A carbonyl carbon is carbon number 5. Yeah, but whatever we are talking about here is not a carbonyl carbon, and specifically it is carbon number 4. So glucose and galactose, they differ at carbon number 4. They are forming an epimer. So galactose is an epimer of glucose at carbon number 4. Yeah, so we want to name this sugar. We want to name this sugar, and remember I said when you are naming this sugar, always concentrate on carbon number 5. And at carbon number 5, we are having OH to the right. So I said when OH is to the right, that is a D, and now this one is going to be our D galactose. This one is our D galactose. Maybe if, but now I'm sure you know how to draw the L galactose. I said it's just a mirror of D sugar. So when you want to draw the L galactose, you simply insert the carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6, CH2OH, H here, H here. The functional group is aldehyde, so we have it there. Carbon number 2, so we want to start mirroring them. Whatever is to the right, we take them to the left. Yeah, so when you check on the D sugar, OH is to the right, so we take it to the left, and H here, and HO. So this side, whatever was the other side, we take it this side. So this is L-galactose. This is L-galactose. I'm sure you are now getting it. I'm sure you are now getting it. So maybe to note something, glucose and galactose, the functional group, their functional group, sorry, that pen, or rather let me write it this way. The functional group, sorry, this board of mine, the functional group for glucose and galactose is an aldehyde. And it attaches to carbon number 1. Yeah, so that is very, very clear. The functional group for glucose and galactose is an aldehyde, and it attaches to carbon number 1. So glucose, aldehyde and glucose, remember we said that if you hear the word OSE at the end, that means a sugar somewhere. So aldehyde plus OSE, yeah, we are going to have, so we are going to remove this one, and we combine this one and this one, and we are going to have an aldose. So galactose and glucose are aldoses. Yeah, galactose and glucose are aldoses, simply because aldehyde is the functional group. When you take aldehyde and you combine it with the glucose, you are going to get an aldose. So we move on. Let's draw number 3, which is now fructose. Number 3, fructose. Formula same, C6H12O, sorry, O6. That is the formula. But for fructose, we are having a different functional group. The functional group for fructose is a ketone. Yeah, is a ketone. So when a ketone is combined with the OSE for sugar, we are going to have, so we'll remove this part, sorry, we will remove this part here, this one, yeah, and now the ket, we combine it with this one and we'll have a ketose. We are going to have a ketose. So for fructose, because of the functional group, we are going to have a ketose. Yeah, and now that's what differentiates glucose glucose, galactose, and fructose. For fructose, the functional group is a ketose. Yeah, ketone is the functional group, and for glucose and galactose, the functional group is an aldehyde. So now let's draw the structure of fructose. Fructose carbon, it also has 6 carbons. 1, 2, carbon 3, carbon 5, carbon 5, and carbon 6, CH2OH. Stick that to your mind. Yeah, carbon 6, CH2OH. It's the terminal carbon. For fructose, carbon number 1 is also attached to H2OH. So at carbon number 1, we are also going to have CH2OH. Yeah, so we are starting to note the differences. So for fructose, the functional group is not attached to carbon number 1, it's attached to carbon number 2. So at carbon number 2, we already having 4 bonds, 1, 2, 3, and 4. So this side, we are not going to have anything. Carbon number 3 is same as glucose. So if you may be forgetting, just rush back to glucose and see what we were having on the right side of carbon number 3, and it was H. Carbon number 4, we are having OH. Carbon number 4, OH. Carbon number 5, we are also having OH. So to this side, if this side is H, this side make it OH. So this one is going to be H, and this one is also going to be H. So we want to name this our sugar as either D or L. And I said we are concentrating on carbon number 5. If OH is to the right, that is going to be a D. So our sugar is a D fructose. Yeah, our sugar is a D fructose. So when you check on this, you can note the difference between the 3 now. Yeah, you can note the difference between the 3. So structurally, fructose is different from galactose and glucose at the position of the functional group, and now that one is known as structural. We are just defining now structural isomer. Yeah, so if you're asked what a structural isomer is, it can also, structural isomer can also mean the same to functional, can also mean the same to functional isomer. Yeah, so if you are told to define a structural isomer, you can simply say same chemical formula, same number of carbons, but different in position of the functional group. So that differentiates fructose and galactose, and glucose. For glucose and galactose, the functional group is at carbon number 1. For fructose, the functional group is at carbon number 2, and the functional group for fructose is a ketone. Hence, we are having a ketose sugar. To draw the L sugar is simply the same. Yeah, drawing the L sugar is simply the same to whatever we were doing to those other ones. So when you want to draw an L sugar, just mirror it. Yeah, because of time, maybe I'll not go into that. Just mirror it. For mannose, let's draw mannose. Mannose also same formula, C6H12O. 6. Yeah, so for mannose, same formula, different structure. So mannose is having a same functional group, as the glucose and galactose. So we have C1, C2, C3, C4, C5, C6, where we are having this C6, we are having the CH, we are having the CH2OH at carbon number 6, CH2OH. The functional group is ketone. Carbon number 2. Now this is where the difference between mannose and the other ones is coming in. Yeah, so this one we are going to have OH here, and the functional group OH here, and here we are going to have H, here we are going to have H, we are going to have HO, we are going to have HO, we are going to have H, we are going to have H. So when you check or you look at this structure, mannose, there is a difference. The difference between it and glucose is at carbon number 2. For glucose, we are having OH to the right. So that brings the difference. So we want to name our sugar, concentrate on carbon number 5. It's a D. Yeah, so this one is a D mannose. If you want to draw the else form of it, you can as well go ahead and do that using the explanations that I already gave before. Yeah, so up to this point I've defined stereoisomer, I've defined structural isomer. So the fructose is a structural isomer for galactose and glucose. Yeah, simply because they differ at their functional group position differ. Yeah, one is on carbon number 1, the other one is on carbon number 2. So we want to move on to the cyclic structures. We want to move on to the cyclic structure now. Now let's do something on the cyclic structures, or rather the ring forms, otherwise known as the Howth projection. Yeah, the other one was Fisher projection. So let's do something on cyclic structures. Okay, cyclic structures. So to draw a cyclic structure, you must have the linear structure at the back of your mind, because without knowing the linear structure you can't do the cyclic structure, and it's very, very important. So I'll do it with an example of glucose. So let's start by drawing the linear structure of glucose. So if you want to make this thing easier, if you're told to draw a cyclic form of a certain sugar, draw the linear structure of it, maybe just at the side. If you have it at the back of your mind, that's still okay, but you can draw it somewhere so that you can refer when you're now inserting the hydrogen and hydroxyl groups. So the first carbon, what's wrong? I don't know, it's misbehaving. It's okay. Let's go ahead. The cyclic structure. Yeah, we start by drawing the carbon atoms. So carbon atom 1, 2, 3, 4, 5, 6. So the sixth one we say it's the CH2OH. Sorry, the first I think there is something wrong. Okay, the first one is where we are having the functional group, the O and the H here, and this one is our carbon bonds, that is the bonds connecting them. So at carbon number 2 we have the OH. Carbon number 3 we have the H. Carbon number 4 we have the OH. At carbon number 5 we have the OH. Yeah, so this other side, if it's OH here, now here we are going to have H, here we're going to have HO, here we're going to have H, here we are going to have H, and now this is our D-glucose. This is our D-glucose. To draw the cyclic form of this one, remember we said that cyclic form for glucose has a 6 corners. Yeah, so it's a 6-membered ring. So when you want to draw the cyclic structure, there's a hydroxyl group. There's a hydroxyl at carbon number 5. Let me just number the carbons so that we don't confuse. So carbon 1, 2, 3, 4, 5 and 6. When we're drawing the cyclic form, the hydroxyl at carbon number 5, yeah, this one here, this hydroxyl at carbon number 5 attacks this double bond here to remove that double bond, so it will remain one bond. Yeah, so from there the reaction we are going to have is known as if you take a hydroxyl, this is alcohol, you react it with the aldehyde, you'll get the hemiacetal that we already mentioned up there. And by the way, there is something I forgot when I was talking about the ketose and the aldose. Yeah, because glucose are 6, they have 6 carbons, so if it's for aldehyde it will be aldohexose, if it's for ketone it will be a ketohexose. That was just by the way as a reminder. So let's proceed. We've said that this OH here, it's supposed to attack this double bond here so that we can have our complete ring. So let's proceed. So when you're drawing the ring, first just have them this way. Yeah, just have it this way. No, that's not straight. I want something that is at least presentable. So here, yeah, that's a bit big, and we are going to have this one here, and we are going to have this one here, we are going to have this one here as well. So here we are having our carbon number 1, it's attached to aldehyde. Yeah, it's attached to aldehyde. Here we are going to have our carbon number 2. Here we are going to have our carbon number 2, carbon number 3, carbon number 4, carbon number 5, and then finally the 6th carbon at the terminal there. So the 6th one, let's just put them. And by the way, if you want to now place these items here, if you want to place these items here now, and this one inside here, yeah, I use the simplest formula for that. And what I do, whatever is on the right, I take them down. Yeah, down in the cyclic. Yeah, I take them down in the cyclic. Then whatever is to the left, I put them up. I put them up. So let's start. At carbon number 1, we've already put that. At carbon number 2, we are having OH to the right, so we'll put it down here. At carbon number 3, we are having H to the right, so we'll put it here. At carbon number 4, we are having OH, so we put it here. It's to the right. Then carbon number 5, we are having OH to the right, so we'll also put it down here. My body is kind of hanging down here. Yeah, so at the terminal here, at the sixth carbon, we are having the famous CH2OH. Now let's start adding what we don't have. So here we have OH, we have OH down here. So up here we are going to have H. Here we are having H. Up we are going to have OH. Here we have OH, so up here we are going to have H. Then up here we are going to have H as well. We're going to have H there. But remember, you can see where our hydroxyl group is, and it's the one that is supposed to strike these double bond, but this distance is quite far, so it can't reach there. So what we are going to do is to rearrange here. Yeah, we are going to rearrange everything around here. We are going to rearrange everything around there. We are going to take this one here, we are going to take this one here, and we are going to take this one here. So what are we going to have? Maybe I should highlight it with the black pen. I said we are going to rearrange. We are going to rearrange here. Yeah, so this OH we will take it here, this CH2OH we will take it here, and this hydrogen we will take it there. Yeah, so let's proceed. Let's draw it again. So we have this one here, carbon number 1, OH. Carbon number 2, we have OH here, H above. Carbon number 3, we have H here. Carbon number 3, we have H here and OH here. Carbon number 4, we have OH here, we have H here. Carbon number 5, we are altering whatever I said. Yeah, I said we are going to rearrange here. So when you come here, we said hydroxyl will go here. I said hydroxyl will come here, and the CH2OH will now come here, and the H will come here. So this one here, we can as well still separate it. Yeah, so we can still separate it. We can remove this hydrogen here. Yeah, we can remove this hydrogen here. So by doing so, we are going to have H. We are going to have O extended to H. So this H, it's this hydroxyl group, it's now very, very free, and it's this hydrogen, let me highlight, it's this hydrogen now that will come and destroy that bond there. So whatever we are going to have next is whatever we are going to have next is so that's what we have after this hydrogen. After this hydrogen has broken that double bond there, so that this hydrogen, it will combine with this hydrogen up here to form OH here. Yeah, the down one will just remain H. Then now we can put these ones. We can now put these ones. So this one was OH, H, OH, H, C, H, 2OH. Here we are going to have our H. Here we are going to have OH. Here we're going to have H. So we have drawn our structure. Yeah. So how do you identify this structure? Also here, yeah, we have something that is very, very unique. Yeah, if you check here, yeah, the hydroxyl group is up, the hydrogen is down. So when naming them, we will name them either as alpha glucose or beta. Yeah, alpha glucose or beta glucose. So for beta glucose, when OH, for alpha glucose, when OH is down. For beta glucose, when OH is up. So when you look at these hours, the OH is up, hence it will be a beta glucose. So these hours was beta and it was a D, so it's a beta D glucose. And how do you now differentiate between glucose and galactose? You simply come to the carbon number 4. Yeah, if the OH is up here, if the OH is up, that one will be a galactose. If OH is down, that one will be a glucose. So that differentiates between glucose and galactose. So this is the ring structure of galactose. When you want to draw for, sorry, this one is for glucose. Yeah, this one is for glucose, beta glucose. If you want to draw for galactose, you'll simply use the same method. Now let's try something on fructose. Yeah, so for fructose, it had a different functional group, which was the ketone. Yeah, so for fructose, this is 1, this is 2, 3, carbon 4, carbon 5, carbon 6, CH2OH. Carbon 1 is also CH2OH, and we say that the functional group is at carbon number 2. Carbon number 3 remains the same. This one remains the same. This other side, we are having HO, we are having H, we are having H, and now we can connect them. Yeah, so when you want to draw a structure for fructose, it's kind of different from that. Fructose is a 5-membered ring. Yeah, fructose is a 5-membered ring. The other one was a 6-membered ring. Yeah, the other one was a 6-membered ring, and 6-membered ring are known as pyranose. 6-membered ring are known as pyranose. Okay, so for fructose, it's a bit different. It's going to be a 5-membered ring, and a 5-membered ring are known as furanos. They are known as furanos. Furanos, or rather the riboses. They are the riboses, the 5-membered rings. So we move on. Yeah, so we have our structure there. For you to draw that, the reaction is simply the same, but now for this one, this OH, it's going to attack this double bond at carbon number 2. Yeah, now it's not number 1. And when they react, they are going to form what is known as a hemiketal. Yeah, hydroxyl plus ketone, a hemiketal. So it happens the same way just as the other one, but now this one we are going to have the O here. Yeah, and we are going to have something that is going to look exactly like this. Yeah, something that is going to look exactly like this. Yes, so this one is going to be our carbon number 1, CH2OH. This one is going to be our carbon number 6, CH2OH. Now we are remaining with the others, which we are supposed to put them here. So this is C2, this is C3. We are going to have C3 here, C4 and C5. So we start replacing them. At carbon number 3, we are having H downwards. We are having H downwards. At carbon number 4, we are having OH downwards. At carbon number 5, we are also having OH. We are also having OH downwards. Yeah, so here we are going to have H, here we are going to have H, and also at carbon number 1, at carbon number 2, after the reaction, after this reaction here, after OH has struck that double bond there, we are going to have a OH that is going to be produced. We are going to have the OH after it has left oxygen. After it has left oxygen here, it will come down here to combine with the O that was here to form a OH. So this is the structure for fructose. And also to name it, we have beta, we have alpha and beta. When the OH is down, it is alpha. When the OH is up, it is beta, just the same as that other one. So this one is going to be alpha fructose. Alpha fructose. So with all these, this knowledge from this one, I'm sure we can now, maybe next time, go to disaccharides and see how they are also formed from these simple sugars. So with that few or rather short discussion, thank you for watching, and again, see you again in the next one.